Hey, welcome back. This Black Beauty is a Pioneer VSX D409, and it's a multi-channel receiver. It's audio-video. It's an older unit. It's only got composite video inputs. No HDMI, no S-video. So it's a pretty old unit. It's got a lot of use. It's pretty dirty. It came with a book and a remote. The remote looks well used and it's filthy. You see that grunge on this thing. Does that look nasty? Anyways, I bought this as part of a lot of 3 receivers and paid one price for all 3. This one and one other one had problems. I can't remember. The original seller took the ad down before I had a chance to capture what he said about it, but he said I think this one had a weak channel or some kind of problem with one of the channels, and I have an Onkyo with one channel that's out. I'll get to that one in another video, but this is one of the ones that needs repair, so I'm just going to test it out and see what it needs for work. First, let's just have a look at it. AM/FM receiver, DVR, VCR, DVD, Laserdisc, TV satellite input, CD, AM/FM tuner built in, auxiliary input, CDR tape monitor. So it does have a tape monitor and a basic treble. That's nice to have those independently, not buried in some menu. Speaker switch. It's got the tuner buttons up here and grouped to one corner, which is nice. And then you got your DTS and your different audio select modes. Of course, a big volume knob and a standby pot. It's actually plugged in right now, but you can't even see the standby light. It's so dim. Turn it on. It works. I don't have speakers hooked up right now. Let's have a look at the back. AM/FM inputs, auxiliary input, CD, VCR DVD input output for the VCR DVD DVR, and then it has input for satellite DVD disc, and then it's got another tape monitor here, in and out for record and play. Output for surround speakers left and right, output for center speaker, and output for subwoofer. And then you got your video input outputs, 2 optical inputs, and 1 coaxial digital input. You got your front speakers, center speakers, surround speakers, and then your B speakers. There is no amplifier for the subwoofer. I guess you have to rely on the on a standalone unit. It's got 1 courtesy outlet, but let's see. This thing was manufactured February of 2000. Okay, so this is a 20-year-old beast. It's got some age to it. I bet you back in the day it was worth a few bucks. Let's hook it up and see how it performs. Turning it on. So we got both channels. Pulling in stereo stations. Everything looks good on the FM. B speakers, A and B. Looks like everything's working. Seems like everything's functional. Just have maybe some bad solder joints maybe, who knows? Channel cutting in and out, it's inconsistent. How does it make that noise? On the lower portion of the silent. Oh, that's coming from my speakers. That's full volume. Okay, let's take the cover off, have a look. Ah, yeah. Okay, look at this. Those big power amp ICs here. I'm guessing we might have a cold solder joint on one of those. And there could be a lot of other things on this main board. Seems like the power supply and the power amplifier is all on the main board. And everything is one unit. So I might have to just take this out and have a look at it. Just to make sure. I got a bunch of voltage regulators down there. Oh, yeah, I can't see it. I'll flip this around so you can see it. Okay, you can see those voltage regulators in there. They're attached to the bottom panel as a heatsink. And we have the AM/FM tuner board, the audio video switching. Oh, there's this video here. This is all audio switching, and probably the DAC is there too. Yeah, this is just going to be going over and cleaning up solder joints, I'm pretty sure. Because as far as I can tell, everything's working. Here's showing. Big power amplifiers. And relay contacts. That could be another thing that could be wrong with this. You can pull those off and clean them. Okay, I think what I'm going to do is I'm going to take out the main board and have a look at the peek at the underside of it, just to see if there's anything weird going on. It is a 20-year-old unit. I can check the ESR on a few caps, but we'll see. Alright, I yanked out the main board, and it pretty much confirmed my suspicions right off the bat. These are the two power chips, and I got cracked solder joints on quite a few of these solder connections here. I also have two transistors. There's main filter caps here. There's two transistors, and then there's a couple of 100 microfarad caps there, and I think it's some kind of a voltage regulator, but the connections on these two transistors were cracked as well. You can see there's a little bit of heat baking going on here. This is dark and this is dark. And I just finished pulling out the ESR meter, and I got high ESR caps all over this board. Everywhere I poked, there's some that are above their limits. So I'm going to do some recapping and resoldering, and I think that's probably the main problem with this receiver, is that when channel cutting out is first the cold solder joints, cracked solder joints, and the high ESR caps on these two. I think it's a regulator. I'm not sure. I have to look at the schematic. But I'll go through and fix all this board up. I'll put all new caps in the power amplifier. I'll put new caps in the power supplies, and we'll go with that for now. And I'll check. Usually, I find that if I find bad solder connections on one board, I have to go through the entire unit on all the boards and check everything, because you're pretty much bound to find more. You're just not going to find it in one spot. It's going to be all over the place. This is a 20-year-old receiver. You know, seems like it's got a lot of use, so we'll just go through it and we'll make sure it's 100%. So I'm pretty much gutting the whole thing, because, you know, once you find cracked solder joints on you know, some of the boards, you got to check them all. And another thing is, especially on these more modern receivers where they have all these plugs and interconnects. This, for example, this interconnect here, they're hard to get out. You always need to check them, because you can get stress along these pins, especially on these big boards. You know, there's a lot of, this is mounted to the back panel, and it's connected and it's secured. This end's secured. This here is floating, but this can crack here. These joints, you can all crack. So you got to take them all apart and inspect them, especially after 20 years. And the best way to do that is get a lens piece and just have a good look. And those are okay, but I'll still need to check those on the other side. And I always check these too, where the inputs are, because these get flexed and these can crack as well. And they don't look like they're soldered very good with much solder. I'll probably, oh yeah, there's a big crack on this one here. I don't know if you can see this on the camera. Let me point it out to you. Maybe you can see that one. Maybe get a better angle at it. You see it's moving. But that's broken, completely broken. And that is, what is that? I think it's a ground connection for this batch here. So that one's broken. And there's another one here. This one's broken too. Get the camera to focus. Maybe not. This one's definitely broken. So I'll go through and fix those up. I'll pull out here's another one. Yes, these ones are cracked as well. These ones are cracked. The one I just disconnected. I'm looking at this connector for the ribbon cable. Usually the ribbon cable ones don't crack because there's enough flex in the cable itself. There's no stress on these connections. But the ones that are fixed, like this one's fixed to the board, and it's fixed to the back panel. So all the stress is concentrated on this one connector. So I'm expecting I'll find cracks on this side and this side. And this side does show cracks. And I'll check. These video connectors, they look okay. This is a video board, by the way. So I'll go through and I got to remove this board and check the underside of that. So I'll do that as well. So I'm just checking the standby LED here because I remember when I first turned or plugged the unit in, that LED was so dim that you could barely see it. And I got it feeding it with 5 volts. I got it disconnected because I don't want to be feeding 5 volts back into the microprocessor or some circuit and blow something up. So I lifted one leg, and I'm just connecting a 5 volt source. There's a 270 ohm resistor here tacked on the back of the board, and when I give it a shot of juice, you can see it's pretty, not very bright. So I think what I might do is I might just change that LED for something that's got a little more brightness, because you could barely see it before. Let me see if I can find one. Alright, so I picked out a water clear LED. It's got a little more brightness to it. It's not one of the super high brightness ones, but it's a little better. And I think you'll be able to see it at least in the daytime. Not like before, it was completely just pathetic. But I just want to say I'm not a big fan of bright LEDs on equipment that's not powered up. You know, TVs and stuff like that, they always got to have that LED on for some reason. I don't understand why, but it's nice to be able to see it if it's there. At least we'll be able to see it now. And it shouldn't be too bright that it's going to, in the dark, it's going to flood the room. One of the things I always do when I get a piece of gear with a vacuum fluorescent display is I always check the backside for the solder connections, because they like to crack. You have a long... Alright, so we got it all back together. Yeah, I had... let's see here, I got a handful of caps I changed out. None of them were really terrible, but there was some that had, you know, high ESR. So this is what I changed out of the entire receiver. I went through all the boards, checked the boards out, and for solder joints and caps, and pull out a bunch. Got it all back together. It seems to be working good. Let's do a power test on it. I got it hooked up to a 1000 hertz tone, and dummy load 8 ohms. Let's try it out. Turn it up. Seems like for the first, doesn't seem to do anything. There we go. Okay, clipping's right there. Let's turn it down one notch. Just get a clean signal. And we are getting 30.2 volts RMS on 8 ohm load. Actually, you know what? Scratch that, it's 34.15 volts. And we'll just let this cook for a while. Seems to be doing okay. It does get hot fast. These power ICs, they just kick out a lot of heat. Quite a bit of humming going on. Let's turn up the frequency. Let's see what kind of frequency response we get. $11 kilohertz. 16, 24, yeah, we're not, oop. I heard something spark inside here. So let's turn it back up. We'll get 24 kilohertz. Let's get it right back up to clipping. And we got 29.36 volts RMS. Yeah, that's hot. I'm not comfortable with the amount of heat this thing put out. My heat sink on the load is quite warm too. Anyways, I think it's a fine working unit. I think we're done with this. I'll put the cover on and wrap it up. Okay, let's turn our attention to this thing. You can see the nastiness of this. So let's, I didn't even test to see if it works. Actually, I could do that right now. I have a card. Well, there's two ways I can do it. I can point this to the camera and press a button, and you can see the light is shining there. It tells me it's working. I'll test all of the buttons. Another one is I got one of these cards from MCM many years ago, and if you, I don't know if you can see that on camera. Here, let's shut the light off. Okay, let's try this. Can you see that? There's a patch of fluorescence here, and it gives an orange light when you hit it with infrared. So it's working. But let's do something with this. Okay, I'm gonna pop this open. We'll give it the full meal clean if we can get it open. Okay. Just the hard part. It's cracking these. There we go. That's all I need. That's all I need to start. It's a tough one. I'm screwing up the remote. Okay, here we go. So what I'll do is I'll take, actually it's not that bad. Got a little bit of grease here, and the oils. This is a silicone compound, these pads, and the oils from your hands go right through the silicone. It's almost like a sponge, and then it goes through to the other side. And you can see these pads, these conductive pads there that they put on the inside of the buttons. They get coated with oil, and what it does is it prevents the button from making a good contact with these carbon traces. So I'll take this out. Okay, so this part is the easy part. What I use is just a little bit of alcohol. And just give it a clean. The pads that get used the most seems to wear. This one right here in the bottom corner is the power switch. See, it doesn't come out very dirty. It's good enough for now. Just want to inspect it. Sometimes the LED, the solder joints crack, and then you get intermittent remote. See, everything seems okay. Everything's secure. So that part's all good. I'm going to put this aside. This part, though, is another story. This needs to be washed. I washed this in hot soapy water under a sink with running water. You get soap on it. Shampoo works good. And get both sides, get all the dust, and look at all this nastiness inside these buttons. It's gross. And then the same thing with this. I usually wash this with a put it in hot water, and you can get it with a brush to get all the mung out. So you can see it's coming down. So anyways, I'm going to go wash these two and come bring them back. Okay, I washed both sides of the clamshell case, and you can see it's a little better, a lot better. There's not much schmeg between the buttons anymore, and the back is clean. One thing you got to pay attention to is where is my screwdriver? Is this where the two halves of the case meet? They part. Usually it builds up with all kinds of nasty stuff in this parting line. You just got to take a screwdriver or something and clean it out. But that's okay, I got it. Clean the pad. It's a much cleaner. You see between the buttons now it's not filthy. And the other side is looking a lot better. So we can just reassemble it. It's pretty simple. And we need, where's our buttons? Okay, this has to go here first. To put this together, I'm going to make sure that those springs go into the slots for the battery compartment. And then just make sure it's all correct. And then from there you just snap it together. It's not that hard. Okay. And if you happen to damage the sides, like I did, just take a razor and just very lightly shave off the bump so you don't feel it with your hand. Here's another one. And with use that'll wear, and it'll look just like the rest of the case. It's pretty worn, this one. And it's working. Alright, thanks for watching.